This lesson is on inverse trig functions. So when you're asked to find the exact value of an inverse trig function, that implies that you should be able to do the problem without the use of a calculator. So if you are not using a calculator with these trig problems, it means you're going to have to use your special right triangles. So always have those handy and ready to go as you're working through these. So opposite our 30-degree angle is 1, and 30 in radians is pi over 6. Opposite our 90-degree angle, or pi over 2 in radians, is 2. And opposite pi over 3, which is 60 degrees, is square root of 3. So that's our 30, 60, 90 triangle in both degrees and radians. So I'm just going to write that. That's 60 degrees. Our 45, 45, 90 has sides of 1, 1, and square root of 2. And this 45-degree angle here in radians is pi over 4. Okay, so what this is really saying is give me the angle that has a sine ratio of 1/2. So let's start by looking at that. We'll deal with this negative once we've figured out the angle that has a sine ratio of 1/2. So we go to these triangles and say, okay, well, which one has a 1 and a 2 in it? So this one has a 1, but it has a square root of 2. So we know we're not dealing with that triangle. So we're going to go to this one. So we have a 1 here and a 2 here. So remember, sine of an angle, we're just going to call that angle theta, is equivalent to the ratio of its opposite side to its hypotenuse. So I'm going to go over here and say which one has an opposite of 1. So opposite 1 is 30 and hypotenuse of 2. So sine of 30 is equal to 1 over 2. So we know that the reference angle we're dealing with is 30. But that's not our answer, or in radians, sorry, pi over 6. So we need to think about where sine is negative on the unit circle. So on the unit circle, in this first quadrant, everything's positive. In the second quadrant, only sine is positive, and its reciprocal function, but we're not going to worry about those right now. In this third quadrant, only tangent is positive. And in this fourth quadrant, only cosine is positive. So, and you can kind of remember this by all students take calculus. They don't, but sometimes it helps as a way to remember. So sine is positive in this quadrant. We're looking for where is sine negative. Well, it's negative in these two quadrants here. Now, typically, these problems will tell you that they want the answer within a certain radian range. So I'm just going to show you how to find both of the answers, and then always just start by giving them the first one. So our reference angle was pi over 6. So I'm going to put pi over 6 here. So we just need to now name this angle. So you always make your reference angle with the x-axis. So that's, you could think of that as 30 degrees, or you could think of it as pi over 6. So if that's pi over 6, we just need to name that from here to here. So remember, this is pi radians. So we want to go another pi over 6 radians. So my common denominator is 6. So that gives me 7 pi over 6 radians. If you want, you can always work in degrees and then convert your answer to radians. It's whatever you're more comfortable with. If you were working in degrees, this would be 180 plus 30, which is 210 degrees. And anytime you want to convert degrees to radians, you just multiply by pi over 180. So now I'm going to simplify my fraction. Both are divisible by 10. 3 goes into both of these. So again, back to 7 pi over 6. Okay, let's do a few more examples of these, and you can just stop the video whenever you're like, okay, I get the idea. So I'm gonna erase this so I can keep working with my special right triangles. So let's say we were looking for the inverse tangent of -1. Okay, so first thing you want to do is think about, well, what trig ratio goes with tangent? So tangent is equivalent to opposite over adjacent. And remember, this inverse tangent is just saying name the angle that has a trig ratio of 1, in this case, of -1, but we always deal with the negative once you have that reference angle. So we're going to write that as 1 over 1. So we want to find the angle out of these two that has an opposite side of 1 and an adjacent side of 1. Well, that narrows it down to this triangle, which is always awesome when we have the 45, 45, 90, because there really aren't that many choices. So tangent of pi over 4 is equal to opposite 1, adjacent 1. So we know our reference angle is pi over 4. So we're halfway there. So now back to our unit circle. Remember, all students take calculus, which means everything's positive here, only sine, only tangent, only cosine. Well, we have a negative value here. So we know we're working in either this quadrant with a reference angle of pi over 4. See how, again, I'm making that angle with the x-axis. Or I know it's this quadrant that we're dealing with a reference angle of pi over 4. So we just want to name both of these angles. So here, all the way to this point would have been 180, or pi. We didn't make it all the way. We were pi over 4 units short. So to name this angle, we have to take pi minus pi over 4. Or you can think of it this way. If pi over 4 is 45, there are two of those here. So 1 pi over 4, 2 pi over 4, 3 pi over 4. So that's equal to 3 pi over 4. And that makes sense because if you kept going, 4 pi over 4 is just pi. So that's another way to divide those up. Or we could just go ahead and deal with our fraction. So that's 4 pi over 4. It's equivalent of pi minus pi over 4, which is 3 pi over 4. Okay, now what if, and again, I'm going to leave some of this. I guess it's a video, so you can always go back and reference it even if I erase it. Let's look at, let's not do tangent. Let's do inverse cosine of square root of 2 over 2. This one's a little trickier because you can't immediately see which of these triangles you're working with. So another way to write that is 1 over the square root of 2. Means the same thing. All they've done here is rationalized the denominator, which means they multiplied 1 over square root of 2 by square root of 2 over square root of 2 to give you square root of 2 over 2. So don't get confused by that. You can always just change it to this notation because now you know you are looking for the angle that has a cosine ratio of 1 over square root of 2. So remember, cosine is adjacent over hypotenuse. So we want the angle that has an adjacent side of 1, adjacent means next to, and a hypotenuse of square root of 2. So if we go over here, adjacent is 1, hypotenuse is square root of 2. So we know that this is equal to pi over 4 radians, or 45 degrees.